Trace. What kind of problem we can solve using decision trees? For example, we need to decide whether to wait for a restaurant, for a table in restaurants based on the following features. Whether there are some alternative restaurant nearby, whether there is a waiting lunch, whether this is Friday or Saturday, are you hungry yet or not, how many people in restaurant, and so on. Based on these features, we can decide whether we can wait in the restaurant in a very long queue or not, or we just go home and eat at home. Okay, so in the decision tree construction algorithm, the most common one is ID3, C4.5, and CART. Okay, so this tree can be classified as greedy algorithm. Okay, so the difference between CART and ID3 is just the metric that you use. CART using Gini index and ID3 using entropy function and information gains. So we're going to talk about the ID3. The other the other decision tree algorithms can include C4.5 regression tree, also random forest. We can use gradient boosting as well, and ADA boost. Okay, how the ID3 algorithm works. First, we need to calculate the entropy and information gain for each attribute. So these two metrics we're going to use in this algorithm. And then the next step is to build the tree based on the highest information gain. And then we repeat the whole process until all branches in the decision tree ended with leaves. Leaf is the decision. So this is the node. We have trees. We build the trees like this until it end up with the decision, with your label. This is called leaves. Okay, there is no more branch under the leaves. Okay, first about the entropy. Entropy is the amount of uncertainty or randomness with a particular variable. Okay, if we thought about another way, is it also the measure of how homogeneous the training samples at a particular nodes are? This is the formula to calculate the entropy. Basically, entropy measures the impurity of a set. Yeah, entropy of S equals to minus sum of probability multiplied by log base 2 of the same number, the same probability. Okay, how to use this? Okay, so basically entropy is this one. How variative is your data? So for example, you have data like this. Okay, your data contains all negative label. So that's mean using the formula below like this, and then your entropy will be 0. Why? Because your probability, the other probability is 0. Okay, so your formula is minus sum of the probability of class I multiplied by log base 2 of class of the probability. Okay, so we want to have the graph like this. Okay, yeah, like this, yeah. Okay, so hyperbolic graph. So at the highest point here, we see that the number of instances that has the positive label equals to the number of the data that has negative label. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Why? Because if we use this formula to calculate the entropy, is equals to half, yeah, half, because this is 1, 2, 3, 4, 5, 5 out of 10 multiplied by log 5 out of 10 minus the same, 5 out of 10 log 5 of 10 equals to 1. Okay, so why? Because log half base 2 of half equals to minus 1. Okay, so the higher entropy means that the proportion is bigger. The proportion of one class is bigger than the other class. Look at this. But the smaller entropy means the more homogeneous your data. Okay, so if we see here, we can have the entropy value equals to, this is minus, the probability of positive class is 0, okay, minus the probability of this class is 1, right? 10 out of 10 multiply by log base 2 of 1. Okay, log base 2 of 1 equals to 0. So remember the log functions, 2 to the power of 0 equals to 1, to the power of minus 1 equals to half. So this is equals to 0. Okay, yeah? So this is the probability of the class with positive label, and this is the entropy. So in here we can see 0.5, the positive class label here, 1, 2, 3, 4, 5 out of 10. So we have probability of half exactly, and the entropy value is 1. This is the highest point. In here, the probability of class P or positive is 0 because they don't have any more positive data in here. Okay, this one is 1. So what happens if all your data have positive label? That means your entropy also 0. Okay. So this is how we read the entropy. If the sample is completely homogeneous, the entropy is 0. If the sample is equally divided, it has entropy of 1. So the highest. This is equally divided. And this one is homogeneous. This one also homogeneous. Okay, now you try which row has the highest entropy.